Aware of the demands of today's motoring world, Volkswagen are continually improving and developing areas of technology to complement their design and manufacturing principles. Like the supercharger, a device designed to increase the volume of fuel-air mixture entering the cylinders, which in turn increases the power output of the engine. The charger is driven directly from the engine itself, using a toothed belt. This is in contrast to a turbocharger, which, although it performs the same task, receives its drive from the exhaust gases which power a small turbine. Volkswagen's G40 and G60 superchargers are so named because they're both spiral or G-shaped. The main advantages of a mechanically driven charger are firstly that it operates at much lower revolutions than a turbocharger, and so is likely to last much longer, and secondly, it's effective at much lower engine speeds. This means that the lag associated with the turbocharger does not occur, and the extra power is delivered evenly. The ignition system of an engine provides the sparks which ignite the fuel in the cylinders. This requires a high voltage and very accurate timing. Fully electronic ignition does away with most of the moving parts associated with older designs, such as the points, and in so doing, eliminates problems due to mechanical wear. The timing, once set at the factory, has little opportunity to drift, and so the system delivers a high-energy spark for longer. This means a more efficient fuel burn for better use of resources. It also gives better starting characteristics, particularly if the battery is a little low. All current Volkswagens are fitted with electronic ignition. Fuel injection is where the fuel-air mixture is accurately mixed together and then delivered to the cylinders either by one central injector or, more usually, individual injectors for each cylinder in controlled bursts or impulses. Such systems are now becoming the standard on Volkswagen vehicles. The main advantage of fuel injection over carburation is the accuracy with which the fuel can be metered, which, as a result, gives much better control over the fuel-air mix. Once again, this means a more efficient fuel burn for greater economy. Just as the human brain receives messages from the senses and reacts to them by sending commands to the muscles, an engine management system coordinates all the other electronically controlled systems from one control unit. Within the electronic memory of the control unit are the criteria to be applied to whatever set of conditions exist at any given moment, such that the engine can be run at its most efficient settings. So the management system must react many times a second to the constantly varying conditions in order to maintain optimum performance. The control electronics receive information from a number of sensors. These include engine temperature, ambient temperature, engine speed, throttle pedal position, engine manifold depression, and exhaust gas oxygen content. The control unit collates all this information and, based upon it, ensures best running optimum fuel efficiency and allows the use of a controlled three-way catalytic converter.